Welcome to my channel once again. Today I am going to say something on chi-square test and its application in economic research. So before going to say the applications, let me say something about the background as well as introduction of chi-square statistic. That is, what is chi-square distribution, what are its properties. These are very important. So let's start with chi-square test. Was developed by Carl Pearson in 1900th century, and the Greek letter chi, pronounced as chi, this is a Greek letter. So we know when a variable is made by taking the sum of squares of some standard normal variables, the distribution that follows the new variable is known as chi-square distribution. And another important term, that is degrees of freedom, is always associated with chi-square distribution, and these degrees of freedom is nothing but that the number of squared standard normal variable. This distribution looks rightly skewed, though its shape depends on its degrees of freedom. As the degrees of freedom increases, it looks like standard normal distribution. Being a sum of square quantity, chi-square distribution can never be a negative value. Hence, it starts from origin. And as we know, for any continuous random variable, the probability density function is equal to 1, total area. The most important thing of Pearson's chi-square distribution is that the researcher can use the statistical methods because it does not depend on normal distribution to interpret the findings. Hence, it may be treated in the category of non-parametric tests also. This is the look of chi-square distribution. Here it is written as degrees of freedom A, degrees of freedom B. The green one is degrees of freedom C. This one is brown one is degrees of freedom D, where A less than B less than C in terms of numerical figures. Suppose this is 2, this is 3, this is 4, this is 5. So as the degrees of freedom increases, it looks like standard normal distribution, and degrees of freedom is the mean value of chi-square distribution also. Pearson's chi-square distribution and so-called the chi-square tests are also known as the test for goodness of fit and chi-square test of independence. These are the two important pillars for chi-square distribution. And another important concept related to the goodness of fit and chi-square test independence is chi-square statistic. That we have to develop this chi-square statistic, which depends on the expected value and the observed value. Observed value means empirical value or given value. And the formula is chi-square equals to summation observed value minus expected value, or the observed frequency minus expected frequency square divided by expected frequency with degrees of freedom k minus 1. K is the number of possible values of the variable. So this is the most important formula. On the basis of this formula, we can able to do many things. And we know that this chi-square test is very popular as goodness of fit test. This test provides a space that can be used to test whether the theoretical probability distribution coincides with empirical sample distribution. It compares the theoretical, that is the expected frequencies, with the empirical, that is the actual, to determine the difference between theoretical and observed frequencies. The most important thing is that it can be said that we can use this procedure to perform a hypothesis test about the distribution of a variable from some observed or empirical values. So on the basis of some empirical values, we can able to predict the distribution of the variable to perform a hypothesis test. Let me explain its applications on the basis of some given example. The example is given in this way, that in the first row it is given year, and in the second row it is given number of motorcycle accidents that took place in a particular state or maybe in country in particular place. And we have to test that whether the above data follows a uniform distribution throughout the time period. So we have to check this or investigate this with respect to alpha equals to 0.05, that means 5% level of significance. The first task is to formulate the hypothesis, our null hypothesis, is the number of motorcycle accidents are uniformly distributed throughout the 6 years. Naturally, the alternative hypothesis is the motorcycle accidents are not uniformly distributed throughout the 6 years. And as we know, alpha is equals to 0.05. So first task is to develop this, calculate the chi-square statistic, that is observed value minus expected value square by expected value with degrees of freedom k minus 1. Since k is here 6 years, 1 2 3 4 5 6, so 6 minus 1 5, so degrees of freedom is 5. And say uniform distribution, that means we can take the expected value as the average of all the accidents in 6 years. So by averaging, this is 352.8, so we can take it as 353. Now we have to put this value in Excel. This is observed value, and as we have calculated, this is expected value 353. Now proceeding to our Excel. So this is our observed value, this is our expected value. How can we proceed? Just click formula, insert function. This is chi-square test, and this is statistical, and go through chi-square test, chi-square test. Click OK. The actual range, give this actual range. Expected range, give this expected value, expected range. Click OK. Okay. So we got this value 0.19. Again, we have to insert, that means formula, insert function, then chi-square interval, chi-square interval. Okay. The probability, we have to put this value is automatically taken. Degrees of freedom, as I told, 1 2 3 4 5 6, so it will be 5, right here 5. So now it is, the value is 7.36. now go to our table value. We have to check table value. This is the table value. So 5 degrees of freedom and 0.05 is 11.07 is the table value, 11.07, and our calculated value is 7.36. Hence we can say that since the calculated value is less than the table value, therefore we have to accept the null hypothesis. Hence we have to accept the null hypothesis, that is number of motorcycle accidents are uniformly distributed throughout the 6 years. Had the computed value exceeds the table value, then we have to reject, we have to reject the null hypothesis. But in the present situation, on the basis of the given data, we have to accept the null hypothesis, since our calculated value is less than the table value with the particular level of significance. Again, giving another example, suppose the example provides that suppose the central government publishes a report about the percentage recruitment in different sectors in the year 2000 in terms of relative frequency distribution in India, shown in figure below in this way. Defense 0.52, bank, education, health. Okay, so this is the central government's report regarding the employment in different sectors. Now on the basis of primary survey, suppose one researcher obtained that or got this information, that defense this, bank this, education this, health this, number of frequencies in this way. Now how can you decide that the employment in your own area follow the national pattern or standard? So how can we decide that the employment in the researcher's own area or state follow the national pattern or standard? How can we proceed? So first we have to formulate that null hypothesis, that there is no difference the pattern of distribution of employment in various sectors. Alternative hypothesis, there is a difference. Now our first task is to prepare this table. So these are the different sectors of where employment took place, and this is the observed frequency, and we have to calculate the expected frequency. This is the total sample size. 50 is the total sample size into relative frequency. In this way we can calculate the expected frequency. Now go to Excel and plot the observed value and expected value or array. Now going to Excel, this is the sheet 15 26 9 15 26 9 26 12.5 26 12.5 7.5 4. So what we have to do, formula same, exactly in the same way. Go, this one is chi-square test, click, write actual value, click, expected value, click, okay, this value. Now again we have to click formula, this one chi-square interval, this value, and number of degrees of freedom 1 2 3 4. Now it is 3. So this value is 15.70. We have to compare this calculated value with the table value. So going to table value 3 degrees of freedom 0.05, 3 degrees of freedom 7.81, and our value is 15.70. Hence we can take the decision that since our calculated value exceeds the table value, therefore the null hypothesis that the distribution is not uniform. There is no difference in the pattern of distribution of employment is rejected. There is a difference in the pattern of distribution. In this way we can take the decision from the given sample regarding the possible pattern or distribution. So here lies the goodness of fit test with the help of chi-square statistic. Now we are coming to, this is another example. This is given as an example for the beginners in economic research, for their homework or task or something like this. You can go through exactly in the same way. This is a type of car: small, SUV, large, luxury, commercial. In terms of percentage, Indian Automobile Manufacturers Association compiled the data on Indian car sales by type of car. Following data shows the distribution in the year 2010. Now a random sample of last year's car sale in India yielded the following data. Now at 5% level of significance, do the data provide sufficient evidence to conclude that last year's type of car distribution in India car sales differs from this distribution? So exactly in the same way we can able to proceed. Next we are coming to this most important or another important test of chi-square statistic, that is chi-square independence test. So chi-square independence test actually is used to decide the existence of association between two variables of a population. Naturally, the null hypothesis supports the negation of any association, and the alternative hypothesis supports the association between the variables. So this is our contingency table, that is bivariate table with some frequencies. Here the density of population in one axis and another axis, various crimes: low density, medium density, high density with certain criteria. And the various crimes means breaking of traffic rules, pickpockets, theft, murder. These are the various crimes. So we want to investigate, does there exist any association between the crime and the density of population? This is our objective. Similarly, we can give another example, that through primary survey we have collected some data on income as well as the education level of the total pooler, and we have formulated this contingency table. In one axis we have taken the education, and it is classified into three categories: low income, moderate income, and standard income. And education level is also classified into three parts, that is nil, up to madhyamik, more than madhyamik. Though this classification depends on researcher or some criteria, on the basis of that classifications can be done. For here, for understanding, we have classified in this way, education as well as income. This is income structure, this is education structure. Similarly, another type of example where we can apply the chi-square independence test. Here two groups are taken, group A and group B, consists of 100 people each. One particular medicine is given to group A. Both the groups are suffering from the same disease, so one particular medicine is given to group A but not group B. Otherwise the two groups are treated identically, and it is found that group A and B, 75 and 70 people respectively recovered from that disease. Now we have to test the hypothesis that the particular medicine helps to cure the disease at whatever may be the method, the chi-square test at 5% level. It may be given or may not be given, but we can apply chi-square independence test such kind of problem also. Now coming back to our initial problem, first problem, that is the density, population density and crime rate. So how can we solve? The steps are written. So step 1, we have to formulate the contingency table by grouping two variables, and we know when bivariate data are distributed with respect to their frequencies known as contingency table or two-way table. Step 2, calculate the row total and column total. Row total, column total. The term outside the bracket actually actual observation, and we have to calculate the expected frequency on the basis of this formula, row total into column total by sample size. So row total by column total divided by sample size, we can calculate this term first cell. Similarly, first column, second row, first cell. So this one 99 into 169 divided by 524. Similarly, others we can calculate, and we know after the calculation of the expected value, we can apply the chi-square. We can apply, as we know that we can apply the excels of the actual value is this, and write the expected value is this, and then we know from the previous example, click formula, insert this function, and this is our statistical chi-square test. The actual value is this one, actual value. The expected value is this. Now click. Okay, we can get 0.2957 this value. Again we have to click formula, insert function, chi-square confidence interval, and the probability means this value, and degrees of freedom now n minus 1, that means column minus 1, row minus 1. So column is 4, 1 2 3 4, so 4 minus 1 3, and row is 1 2 3 4, 3 into 3, that means 9 with respect to 9. Row minus 1, column minus 1, so 3 into 3, 9. So we are getting 10.75, 10.75, sorry 10.715, and that means 10.72. Now we have to compare this with respect to 9 degrees of freedom. This is 9 degrees of freedom, 5% level, 9 degrees of freedom, 5% level is 16.91, 0.05, significance level 0.05, and degrees of freedom is 9. So coming to this row, 16.91, and our value is 10.71. Naturally, we can take the decision that our null hypothesis can be rejected. Null hypothesis means there is no association between the density of population and the various crimes. So on the basis of the given information, we can take the decision that we can reject we can accept the null hypothesis, because our actual value is less than the table value. Calculated value is less than table value. Okay. Therefore, we can accept the null hypothesis. That means there is no association between the density of population and crime. Since our calculated value is less than the table value, therefore, with respect to 9 degrees of freedom and 0.05 level of significance, we can take the decision that we have to accept the null hypothesis. That means there is no association between the density of population as well as the various crime rates. That's all. Thank you. If you like this concept, requesting you to subscribe this and share this. Thank you.